All right, so here we have our friendly absolute value function. We worked with this in our last unit. We can see that a value is 2. It's an absolute value of x, which gives us the v shape. Because the a value is 2, we know that from the vertex we went up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and then got the points on the other side to create the other half of the v. So great, we know all about that graph. But how is f of x equals 2 times the absolute value of x related to a linear function? So remember, a linear function is going to be a function that is a straight line. Well, when I look at this, the whole thing is not a straight line. I can see a straight line on the right side and a straight line on the left side, so it's got two pieces that are straight lines. So what we're going to write in our notes, how is it related to a linear function? The graph has two pieces that meet at the vertex. Each piece is part of a line. That's how it's related to the linear function. Okay, so find a rule for each piece of the function. Well, that means we're going to write a rule for this line and for this line. So we can see that we have this kind of imaginary vertical separation between these two lines. This is happening at when x is 0, at that vertical line. So on this side, that's when x is less than or equal to 0. And on this side, that's all of your x's that are greater than or equal to 0. So the reason why I am pointing that out is I can see that we have this line. If I read the graph from left to right, it has a negative slope. This line is happening on this side of this vertical line when all those x's are less than or equal to 0. Once we get to the right side of that vertical line, I can see that we have a different line. We have a positive slope right here, and this line is on the part of the graph where all the x's are greater than or equal to 0. So we're just going to write that out. This line on the left right here, if we start just on the left side, let's see what our slope is. If I kind of track from one point to another exact point, I can see we're going down 2 to the right 1, down to the right 1. So that has a slope of -2, and I can see it's hitting the y-axis right there at 0. So that equation would just be y equals even wrote it wrong, negative 2x. This line on the right, if I kind of look at the slope, I can go from just an exact point to an exact point. We're rising 2, running 1 to the right, rise 2, run 1 to the right. That has a slope of +2. We can see that this line also is hitting the y-axis at 0. So this line has the equation y equals +2x plus 0, because that's that y-intercept. So what we're going to do is we're going to put this together as one piecewise function. We're going to say f of x equals, and we're going to give ourselves one of these brackets. We're going to have two lines of our function because we have two pieces of this function. The first one is going to be this function we put on the left side, just this -2x. I don't need to write the y equals because this f of x equals takes care of this y equals, but we are going to write that -2x. Then we just have to tell everyone, all right, well, where is the line a -2x? Remember, we said down here, this is where this line happens, where all the x's are less than or equal to 0. So we just put a comma and we say we're going to have this line, but only for the part where the x's are less than or equal to 0. We just want that piece of that line. We also have another line over here. We already said the equation for that was y equals 2x. So this y equals is taken care of right here, f of x equals. So we're just going to put a 2x. So we have f of x equals 2x. But what part of the line do we want? What piece of that whole line? We only want the piece where the x's are greater than or equal to 0. So we just put a comma after, oh, I already did the comma. We're going to say for all the x's that are greater than or equal to 0. That just tells us what piece of that line to keep. And that's we wrote a piecewise function for that absolute value graph. Kind of fun, right? Okay, so next question, express f of x equals -3 times the absolute value of x as a piecewise defined function. So that's what we just did. We just took f of x equals 2 times the absolute value of x. We looked at a graph of our function, and then we broke it up into the two pieces, the left side and the right side of that V. So why don't we start there again? We're going to just do a quick sketch of our graph. We have f of x equals -3 times the absolute value of x. So if we sketch this graph, when that a value in front of your absolute value bars is negative, that means this is going to open down. And because we have the absolute value of x, we know that this is going to be a V-shaped graph. We can use that -3, kind of treat it like slope. Our starting point is going to be at the origin, and then we can go down. I'm going to give myself some more dashes. So what we'll do is we will go down 3 because of the -3, down 3 to the right 1. Then we'll go down 3 to the right 1, and we'll just continue that pattern. Again, we're just doing a sketch. So down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1. That's getting us this side of our V, and then we know we'll have those same points on the other side if we go down 3 and to the left 1, down 3 to the left 1. Okay, so this is our absolute value function, but it's also a piecewise graph because it has two pieces. We've got this left piece and this right piece. So what I want to start by doing is finding where it switches from one piece to the other piece. This is that vertical line that we drew in before. That vertical line is when x equals 0. Now, what we're going to do is we're going to just make sure we're writing in on this side, on the left side of that line, that's when x is less than or equal to 0. And on this side of that line is when x is greater than or equal to 0. So what we're going to do is we're going to come up with the equation of this line and the equation of this line. And then we've already talked about which piece of the line we want to keep. We want to keep for this line the piece where all the x's are less than 0, and over here we want to keep the piece where all the x's are greater than 0. So over here, this left side, again, if we read the graph left to right, we can see it's increasing, so that will have a positive slope. And then what is that slope? We would go up 3 over 1, up 3 over 1. So on the right side, we have the function y equals positive 3x, and then the y-intercept is up here at 0, so plus 0. So we can just say y equals 3x. Now this right side, this line is down 3 to the right 1, down 3 to the right 1. So that function is y equals -3x. Again, I can see that our y-intercept is 0. And so we're going to put this together as one piecewise function. We're going to say f of x equals, give ourselves a bracket. So we'll just work left to right. Our first line was this y equals 3x. Again, we already have f of x equals, that takes care of this y equals. So we're going to start with 3x. And then we just have to say, well, which piece of that line do we want? We want the piece that has where all the x's are less than 0. Now here's something that I kind of made a mistake on up above, so I apologize, we'll make this mistake. When x is equal to 0, this one spot, I can't say that it's on this line and on this line. it's only going to be on one of the lines. So we're just going to put this point at 0 on the greater than side. So what I'm talking about is this is going to be a greater than or equal to 0. And this side, we're going to switch that to just a less than 0. Again, the reason for that is just that when x is a 0, it can't be part of both functions. It can only be on one of the functions. So we can't say that they both equal 0 on the left and on the right. All right, so back to our piecewise function. We've got f of x equals 3x, comma, what piece of that function do we want? We want the piece where all the x's are less than 0. And then over here we've got this function, which we already figured out was y equals negative 3x. We have our f of x equals, we're going to write in a negative 3x. And then what piece of that line do we want? Just the piece where x is greater than or equal to 0. And there's our absolute value function, just written as a piecewise function, the two pieces for each side of that v. Now we do need to come up and fix up here, just for consistency. When we have these absolute value graphs, we can't equal 0 here and we can't equal 0. So we're going to keep the or equal to on the greater than side. Let's change this one to just x is less than 0. Okay, I know this was a long video. Thanks for hanging in there. Hopefully it's starting to make some sense.